good afternoon or good morning, good evening, wherever you are in the world, and welcome to our launch webinar for the C3S Climate and Energy Education Demonstrator. I'm going to give it just a very quick introduction and agenda, and we will take you through the instructions about how you can ask us some questions and whatnot. So my name's Kit Rackley. You can see there I'm on the agenda on number 6, so I'll be talking again a bit later. We are very delighted to be joined by Carlo Buontempo from ECMWF, who's going to give us a little bit of context from the Copernicus point of view, and he will start us off in just a moment. And we're also joined by Filipe Moura, who's our development lead from Nth Work, and we're very delighted that he can join us from Portugal too. And then the rest of the team, as you can see, they're all of us here from WEMC. So just a little bit of housekeeping. We are very happy to take questions from you, and you can do that by using the questions tab here on GoToWebinar. So if you look at the console, you see there's a questions tab, and at any stage, you don't have to wait to the very end. At any stage, you can type your questions, and then we'll go through those at the end. So as you can see from the agenda, there will be a demonstration with regards to how the tool works and what you can learn from the tool if you're going to use it in a classroom. And we'll also let you know give you the chance to access it yourself and have a play around with it. So let's get us started. I'm going to pass over to Carlo, who can give us a little bit of context with regards to Copernicus and ECMWF's point of view.
Okay, thank you, Kit. I'm Carlo Buontempo, and I'm the director of Copernicus Climate Change Service. And what I will do now is just to give you a very quick introduction about Copernicus Climate Change Service and Copernicus as a whole, as a program, before getting into some details of what C3S is doing. So Copernicus is a European program and is mostly a satellite program, so atmospheric or satellite remote sensing, so looking at the Earth from space. And most of the effort is devoted to design satellite, launching satellite, retrieving the data from satellite, and so on. And this is the so-called space component. But alongside the space component, there is also a service component that is structured in 6 different services, so atmosphere, climate, land, marine, emergency, and security. And 2 of these services, atmosphere and climate, are run on the behalf of the European Commission by the European Centre for Medium Range Weather Forecast here in Reading, also known as ECMWF. So I won't talk about the other services. I will only talk about C3S, so the Copernicus Climate Change Service. And this is what you can find on our webpage, so climate.copernicus.eu, and there is a mission statement to provide authoritative information about the past, present, and future climate, as well as tools, and I will come back to tools in a few minutes, to enable climate change mitigation and adaptation strategies by policymakers and businesses. So that's what we're doing. Is a bit of a mouthful as a mission statement, but it contains all the essential aspects. And still, it misses one important component, which is the fact that we are an operational service. And by operational, I mean that we provide access to high quality data and tools and information, but also that we provide all these accessory elements such as user support, training material, quality control, and so on and so forth, that guarantee us use of the data and ability to develop applications. Given the dependence of climate change in the media, I don't think I need to spend too much time highlighting why climate change is a challenge for our society, and to make usable this huge volume of data that we have. But the other one is to provide some sort of a solution or a way to tackle fake news. So given the prominence of climate and climate change and the size of data set, how can we provide a set of tools that allows you to check by yourself whether what we are saying is robust, is solid, is traceable? So these are the challenges we are facing. At the center of our proposition is something that we call the Climate Data Store. So it is a unified web-based access point to this huge volume of data. And this little icon you see in the background represent different products we have on the catalog, going from old observations, so past climate observation, reconstruction of the past weather, to climate projection for the next 100 years. So we try to characterize the atmosphere, the land surface, the ocean in the best possible way for the last few hundred years, as well as the projection for the next 100 years. And we have at the moment some 30,000 users registered, and we deliver some 50 terabytes of data per day. But alongside the data set, as I was mentioning before, we also develop an in-cloud environment that allows you to manipulate the data without the need of downloading this huge volume of data set we have. So if you want to make it accessible, then you need to have these tools available on the fly. And finally, all we have is quality control. So the tools that you have, the data set that you have, come with enough information that allows you to make a judgment on whether that data set, that application is fit for you and for your purpose. And as part of this exercise, we have developed a number of demonstrators, a number of applications addressing sectors as different as energy, water, insurance, agriculture, and so on and so forth. And we are very keen for this application to go even beyond these traditional sectors and permeate different parts of society. And clearly, schools and high-level training institutions are one of the targets, and that's why I'm so excited about this specific project. I don't think I need to say much more in my introduction, so thank you for your attention.
Okay, thank you very much, Carlo. We lost Carlo's audio for just a few seconds there, but that's not a problem. You came back, and also if there's a specific question when Carlo was talking about that particular element, please do send the question there in the question box, and Carlo can just clarify what he was attempting to say. But it was only for a few seconds, and we got you back very quickly then. Okay, so thank you very much, Carlo. That's excellent with that insight. So we're now going to pass on to Alberto Troccoli here at WEMC, who's a director here at WEMC, and he is the project lead and can give you more about the background which formulates our project. So over to you, Alberto.
Hello, everybody, and thank you, Kit, for the introduction, and Carlo for just providing a bit of background around C3S. So I'll provide some background, brief background about the education demonstrator. So we were meeting with stakeholders a few years ago to work through what is the predecessor, let's say, of the demonstrator, or what we got inspiration from. So here on the bottom, you can see the European Climatic Energy Mixes demonstrator, which is a project that was developed under C3S, started about 3 years ago, led by University of East Anglia. And this was built with a lot of input from a number of stakeholders. As you can see, we run several stakeholder workshops. So this is all well and good, and it allowed us to address questions like whether there's going to be enough water to fill a dam in 10, 20 years or so, as well as several other questions like, for example, will there be enough solar power or wind power, and will there be extreme events such that they might destroy actually our wind farms? So this are all important questions. But they were mostly refined and contained within the area of specialists working in the area of energy, and that was the purpose of this exercise. But then we thought, you know, what we are dealing with, the data we are producing with the demonstrator and the questions we are addressing are actually bigger than that. I mean, there are things that we can relate to what is happening in the bigger picture, where, you know, we can see that obviously because of the high level of greenhouse gases that are emitted now on the screen, you can see the high levels that are unprecedented in historical terms back to 800,000 years. And this obviously caused several events that are beyond the energy sector, and that's where we thought, you know, that's something we can use to communicate also with the wider audience. And this wider audience, we thought it could be something that, or someone rather, who can help also understand better what's happening with the climate. And this is the youth, the new generation that is coming up through schools. And that's where our vision for the demonstrator came in. And at about the same time, actually, after we started, the demonstrations, all sorts of demonstrations, as you would know, were happening on the street with school strikes all over the world. And so we see this as a great opportunity with the tool that we have developed to make something that is more approachable for students, high school students in the first place, but then hopefully also beyond, because the way we approach this is to try to make it more accessible to wider audience than just a specialist in the energy and climate sector. And I would like to stop at that, and I'll get back to you later with question and answer session. So over to you, Kit. Thank you.
Okay, thank you very much, Alberto. So we now move on to Elena, who's just going to give us a couple of minutes about the approaches to the design. So over to you, Elena.
Thank you, Kit. My task for this project was to simplify complex data and create an easy, interesting user experience, but still have a scientific look and feel. So the concept was made easily to engage through, I hope, a new, fresh approach. Our main targets and audience, as Alberto mentioned, was particularly students and teachers. So I tried through simple lines and color and to give a really a fresh, modern look. Tailored design was a simplified, icons helped navigate the demo and create a unique experience. So on my second slide, you can really see as you're landing a very colorful and modern look and feel. So on the top left, you have the climatic and energy variable icon. The colors are very bright and the lines are also very simple, but you still have a perception of a menu. So also the map, it's a combination of geography and abstract. So I really hope with this modern touch to give an inviting use of the demo. Also on the right, sorry, you have the graph. So the graph is made in some way a little bit easy and modern to look at it. So clean lines provide an inviting access to the data. And on the bottom, you can see the time slider. Again, I go back to a very simple line, the clock, the time clock. And so on that, I really hope they will be able to use it and play with it. So overall, my task was again to give a fresh look and feel, which I hope students and teachers will be happy to use. And so, thank you.
Okay, thank you, Elena. That's wonderful about the design. So, and you'll see how the design in a few minutes' time, when we show you the demonstration, you'll see how that design works with the operation of the tool. And quite timely with regards to the operation of the tool, we can talk a little bit now about the development itself. And we're going to have Luke Sanger here and Filipe Moura take us through. So those of you who are interested in particularly the development and how all the back end works and what's gone into actually formulate the tool, we're now going to be taken through that through Luke. So if I pass over to Luke, and over to you.
Thanks, Kit. Yeah, so my role in the project has been to help translate our technical needs for the educational demonstrator between the team here at WEMC and our developers at ENF. And Filipe from ENF will go into more detail in the technologies used in development in a few minutes. So for now, I'm going to explain about the database that we use as the backend for the educational demonstrator. As explained earlier by Alberto in the webinar, the C3S Education Demonstrator is built on the foundations of the ECEM proof of concept demonstrator. And essentially, the educational demonstrator uses the same database as the ECEM, but provides a new and more accessible front end on top, aimed more at students, whereas the ECEM was more of an industry targeted tool. So the data itself is built using ERA interim data as described by Carlo. It's the data comes from the Climate Data Store, and these links are provided for reference if you want to read more about them. The current data set covers the European region and has temporal or time resolutions covering daily, monthly, seasonal and yearly timeframes. So it's possible using the demonstrator to plot data, view data based on these timescales. So whether you're looking at summers or certain specific days where there may have been a certain event happen, you can do so. The data set itself is organized using CSV files, and without going into too much detail, the CSV files have very specific file names which describe the data contained within. The CSV files are accessible by the user of the tool, and the advantage of this is they can download any of the CSV files used in the demonstrator for their own purposes. So it may be that they'd like to run the data set using their own software, perhaps for a school project. They may be learning a particular piece of software that they'd like to try, and they can use data from our demonstrator in other applications. We chose to use CSV files instead of climate science specific file types like NetCDF, because CSV files are very lightweight, and they're a standardized format used universally across all computing and information technology as a whole. So any platform really should be able to handle a CSV file. In that respect, it should be easily accessible for all students, teachers, and industry professionals. And going forward, these are kind of possibilities, considerations for how we may extend the database in the future. For starters, the ERA interim dataset has now been replaced by ERA 5 on the Climate Data Store, and we'd like to update to this dataset. The advantages of this is it currently goes from 1979 up to the present day. It's higher resolution in both time and scale. So in terms of time, the data sets are hourly, whereas currently on our demonstrator, the lowest time resolution is daily. So we had the potential to go to hourly resolution. The database itself has improved modeling and is a higher quality data set. And one of the best, or one of the big advantages, I should say, is its ERA 5 is near real time. So the data sets are being updated with only about 5 days lag. So the advantage of that is the demonstrator could potentially be an operational system and continuously updated. And finally, the potential with ERA 5 is that it's a global data set now, right, as opposed to Europe, and we potentially could extend to the whole globe for the application. So that is about it for the database from my side. I'd like Filipe will go into more detail in terms of the technologies used for the demonstrator.
Okay, thank you, Luke. So I will rush transition there, so I'll go straight to Filipe. So Filipe, the presentation is yours.
Great. Hello, everyone. So as a very high level overview, so I can share my screen first. Yeah, so a very high level overview, we started the project with 3 main requirements, which were to provide a great user experience, so easy to use, intuitive, and by easy to use, we also mean as accessible as possible to a wider audience, as Alberto mentioned. But if you think about our new audience, which is like classroom, so we're talking about students using like computers at school, or maybe mobile phones, or maybe tablets, and teachers and stuff. So we had to have a user experience that would work across multiple devices, and that impacts the technology a lot, because the technology choices we have to make to have a product that will work across multiple devices are different, as I will show in a few next slides. So we also had to be as accurate as the original demonstrator. So we had to be working with like libraries and software that would be able to handle data with accuracy and making whichever modifications or data handling we needed, and something that would be extensible for further regions and data sets. With those three requirements in mind, we had a few decisions to make, and we moved from what was the original ECEM demonstrator, which was a browser-only implementation. So all the processing of the files, the CSV files, was handled by the client's browser itself, which could impose some restrictions if you were thinking about multiple kinds of devices, and also would be a bit challenging to extend that data set, because the code starts to get too confusing. JavaScript on the client side is not the right technology to handle huge assets of data and stuff like that. So there were like challenges to go in that direction. So we moved to a new architecture with a client front end intended to be very light, would not be handling any data, just presenting the data to the user, and the backend provided the data via an API. And this backend could be as complex and as powerful as possible to handle all sorts of data and simply provide JSON CSV files to the front end. So the front end, we end up having a very lean set of technology. So we are using a framework called Angular from Google, And what Angular does, it allows you to build rich, complex web applications like Google, for Gmail, for example, is built in Angular and other things like that. But at the end, what you have is just a set of HTML and plain JavaScript files, static web pages, which can be cached in multiple levels, so performance can be brought. So data can be the page can be very lean and very optimal. We also use the library called AM Charts, which is a very powerful JavaScript library for graphs and maps and all this kind of like data visualization. What you see in the demonstrator, the map and the graphs is just like a fraction of what can be done with this library. So for further data sets or for further visualizations, we have a very powerful base to extend on. And we are using things like local performance of the application. On the backend side, so having data extensibility in mind, future like different formats of data sets and maybe possibly more complex data handling, we implemented a backend all based in Python and Python data analysis packages like NumPy and Pandas. So it's basically I would say it's the most used data science / data analysis like set of packages. So we can handle like all sorts of data sets and huge data sets, because all that processing is handled by the server side and can be cached, and you can leverage all these technologies to have great performance and data quality. At the same time, the API separates that data from the client side implementation. So if in the future we want to use the same data sets or the same data manipulation to other demonstrators or other applications, or to provide that data to other web services, whatever, whether the API kind of handles the data, manage the outputs, and we can kind of like decide who's that going to be provided to through an authentication layer that guarantees who can access what and etc. That's it from the technology. I'm happy to have any questions later, and I'll hand it back to Kit.
Okay, thank you, Filipe. So please do keep the questions coming in. So that kind of does the background side of the webinar, and you can have the questions come in at any time. So specifically, if you have any questions with regards from the background point of view. So what we're going to do now is that we're going to show a pre-made video that we've done for you, given an 8-minute demonstration of how the tool works. So we take you for a whistle-stop tour of what it's capable of doing, but also the last few minutes will also demonstrate how it can be applied in an educational setting. So obviously we want you to see the wood through the trees. So me and Luke are going to set it off for you now. This is the Climate and Energy Education Demonstrator, a tool developed to allow you to explore climate and energy variables from historical data to future projections. This tool will show you how the main functions of the demonstrator works and give some examples of how it can be used in a learning environment. When the tool first loads, you are presented with a globe showing the latest historical average annual temperature for Europe, instinctively showing blues for cooler areas and reds for warmer ones. Under the variable icons, you can change how the data is displayed on the map and on the graph with these filters. For the currently displayed variable, you can also download the data as a CSV file and a PDF fact sheet which gives you interesting information, facts, a mini case study and glossary. During this demo, you'll see some of these features in action, but let's start by showing you how we can get an even finer spatial scale to look at temperature spatial patterns across Europe. The pattern of average annual temperatures has become even clearer, and you can even see the differences within countries very clearly. When we move the mouse cursor to hover over an area, its data point will pop up as a tooltip. The legend in the bottom right is also dynamic and has been designed to interpret the map. Notice as I move the mouse cursor over the map, an area's data value appears in the legend over the corresponding color category. This feature will help users to understand how CorePath mapping works, and this demonstrates that the tool can be used to practice graphical skills as well as messages that come from analysing the data itself. Let's have a closer look here in the bottom right at one of the most powerful but simple functions of the tool, the slider. Notice that the left side is coloured and the right side is hashed. That's because the tool can cycle through historical data, currently 1979 to 2016, but also onto projected data onto the future and climate models up to 2100. In one simple click or drag to the end of the slider, we can learn one very important message. Ready? Keep an eye on the map. Notice how there are fewer blues and more reds and even darker reds on the map. Instinctively, we can tell from the map that Europe is projected to warm during this century. This map is now showing projected annual average temperatures for 2100 under a high carbon emissions scenario. Again, just using a single click, we can explore changes to a deeper level. Let's take the Swiss Alps, for instance. Now the graph is showing how the selected variable changes in time, from recent past into the future, and lo and behold, it only needs a quick glance to see that indeed warming is not only expected to take place, but the historical record, represented by the orange line, clearly shows that warming has already been occurring. The blue and purple lines show the changes in temperature based on climate models, purple under a high carbon emission scenario and blue a low carbon emission scenario. You'll notice there is some information above the graph, giving you some highlight figures. The temperature for the Swiss Alps, averaging out the whole temperature record between 1981 and 2010, was 3.36 degrees Celsius. We call this the long-term mean, and you can see that represented by the dashed orange line on the graph. But no matter what the emission scenario, low or high, you can see those blue and purple lines rise above that average figure. The tool can display more than just temperature. It can plot a number of other climate variables and some energy ones too. The other variables are wind speed at 10 meters in height, total precipitation, solar radiation, solar PV energy, electricity demand, and wind energy. Let's have a quick look at one of the energy variables, electricity demand. Here we can see the historical patterns of electricity demands across Europe and what they are projected to be based on different energy scenarios. The ability to change the temporal scale for any one of the climate and energy variables can help us to explore patterns even further. Changing from annual to seasonal, for example, shows us how electricity demand changes between different seasons, and this can help spark investigations on why this might be the case. Dragging over an area of a graph allows you to zoom in and explore the differences in data a little bit more closely. So, those are the basics, and I think you'll agree that even though we are yet to play around with other variables, options and filters, you can already learn quite a lot. So, what might this learning look like? Well, the tool is designed to allow teachers to set their own learning objectives. It is essentially a geographical information system, or GIS, and so lends itself perfectly to inquiry-based learning in particular. So let's have a think about this inquiry question. Will extreme weather events today become the norm in the future? Now, one approach to this question is to look at the data from one or more extreme weather events that students may have studied. Since the tool allows us to explore historical data on a daily scale, we can see their signals clearly on both the map and the graph. The 2003 European heatwave, for example, was exceptional and deadly, resulting in 70,000 deaths, with the country of France suffering particularly. What is worth noting, and really quite incredible, is that these are average temperatures for each 24-hour period during the heatwave. So it includes the relative cool of nighttime. In fact, daytime temperatures broke 40 degrees Celsius in France. But could this abnormal extreme weather event, such as heat waves like this, ever become normal in the future? Well, let's average out the temperatures by season and look particularly at summer. There is that summer of 2003. Wow, that is a very clear extreme heat signal in the data. Now, if we look at temperature anomalies, which is the difference compared to the 1981 to 2010 average temperature, we can see that the summer of 2003 in France was 3.25 degrees Celsius warmer than average. So, the question is, when will similar temperatures become a frequent, almost year-to-year occurrence? Well, the graph makes it very clear to see. So by the 2070s, under a high carbon emission scenario, a summer like the one in 2003 could be seen every year, and beyond that, even warmer. And although the low emission scenario temperatures on average don't quite get there, they certainly will mean such extreme weather events will become more normal and more frequent. Now, no matter what European country we click on, we can see the same warming trend. So we can conclude that the extreme heat wave events that have been taking place in Europe recently, such as those in 2003, or even more recently last summer, are projected to become normal conditions by the 2070s. Thanks for watching, and we hope you're now really looking forward to giving the tool a go yourself. Okay, I won't dwell, based on my part in statement on that video there, I won't dwell too much on this because some of you might be itching to have a play yourself, which we're going to provide you with a link in the next slide. But just to make you aware, to expand on that a little bit more, so we do provide some educational material. We're working on these at the moment. These are all in development. So every variable, there are 7 as you've seen, have a fact sheet that go with them. 5 of them are live at the moment and 2 are just about to be finished. And they produce, they have a glossary, they have did you knows, and we try and keep them very, very student centered. So there's even a little element about being data smart, so a little bit of critical thinking on there. So we try to have a bit of a broad base and just 2 sides of A4 there. There are some mini case studies. Most of these are attached to the fact sheets, but we're going to see if we can have some of these separate too, which basically just gives some real life context to the data. And the other thing we'll be working on in the near future is some snippet videos, which again kind of take like these are videos which are about 3 to 5 minutes long, which have a look at the data and demonstrates the tool in use of how to learn certain aspects. So this screenshot is showing you this is just a pilot, a proof of concept example here. That you can see about solar radiation across Europe, and all of these things are accessible via the menu. So when you go to the tool and you go to the menu in the top right and you click on the resources button, you'll be able to access all of these things. Okay, so I'm guessing that the majority of you will be aware already of the tool because it's been quite well promoted, and thanks to our colleagues and our friends over at Copernicus who've been sharing this as well. But if you haven't, and this is your first time, this is the web address, https c3s-edu.wemcouncil.org. So that will take you to the tool itself. So do feel free to, as we're going to go through the questions and answers now, this is a good time for you to kind of have a play around. We're quite happy to keep this, so we've got about 15-20 minutes left, so we can, if you have any questions that come up while you're playing around with it, so that you can pose them through the webinar here. This is just a screenshot of a tweet here from a colleague of mine here in a geography teacher here in Norfolk, just to prove that we have had student and teacher engagement in the development stage. We got Alberto Academy and their students to try and break it. So their hackers club did try to get into it and basically find as many bugs as they possibly can for us and give us loads and loads of feedback. And they were lovely with that. We got some brilliant response from those students that really helped us in development. So we want to continue this feedback. It's just because we're now live, it doesn't mean we finish. We always want to improve and want to make this the most accessible tool to observe climate and energy data as possible. So when you go to the tool, you'll notice that there is a little feedback button on the right hand side of the screen, which will give you this lovely pop-up with these excellent emoji faces. And quite simply, you can just click an emoji face and click send. But of course, we would absolutely be grateful if you could give us a sentence or two about how you feel, what you think, what you'd like to improve, what you'd like to see, what you like, whatever it is. And then you can click, if you want us to engage in a dialogue with you regarding your feedback, then obviously you can give your consent for us to contact you, and it will ask you for your email address there. Okay, so as you go around and play with that tool, perhaps, I will now pass it over to Alberto, who is going to be the compare for us for the question answer session. So Alberto, I think it would be fine to leave the screen on me, but if you want to take the con.
Yes, so thank you, Kit, and thank you also for the attendees to stayed with us up to here, and also for already having put some question on the panel. We got Bernd is asking about plans for the tool to be available in multiple languages. So I would like Kit perhaps to address this question. We've discussed it several times, and Kit, you'll be able to provide an answer, and other people want to join as well, please.
Okay, sure. Yes, so we most certainly do have ambitions. This from the very start. We knew it was very important that we wanted to make this as accessible as possible. So that includes as many different languages as possible. The way we've been working this is that we've been engaging with we've got a wide network here at WEMC, and we've been able to engage some of our colleagues who have been willing to do some translations for us. So we do have a volunteer who we're going to try and get translations into French. This is both this is at the very least the tools interface, so the front end interface, so helping us translate it into French. And we potentially have another volunteer who may be doing it into Polish as well. With regards to the educational material, of course, that's a little bit more legwork because there's more words involved. We want to make sure that the context is correct, not just the language is correct. So the way we've been approaching this is the way that WEMC works really in itself, is that we try to utilize our network and all work for the common good. So if anybody is out there who is willing to help us do a bit of translation, whether it is, it could be a few sentences or a paragraph or just a bunch of keywords, then we can compile things that need translating, and we'd be very happy to ask for volunteers in that respect. And you can contact us, and there's our email address is on the last slide here, and we'll be very welcome if you can contact us.
Okay, thank you, Kit. And I would also like to acknowledge on this point the contribution from Laurent Dubu, who's is liaising with schools in France. And I should also say that the development of the demonstrator as it is has started from the like a limited area around the Norfolk and UK region for practical purposes, not because we wanted to give some sort of priority to the country, but it's always the way you project develops. So you start with an area and then develop further, and that's the idea. And through also the activities of WEMC, one of which is also led by Kit, is the special interest group on education. And through that, we've been also talking with people from different parts of the world who, as Kit said, also are providing their input, and also they are volunteering to help with the further extension to other languages. And it's not just the languages, it's also the curricula. So we have to watch that we don't, we're careful when we provide the material that it is following the curricula on particular countries that we are looking at. Okay, so in terms of other questions, there are some other questions that are a bit more technical, and we thank for that. But there's one around use of netcdf files instead of CSV, for example, and we'd be happy to, of course, address this. But this is actually a bit beyond the scope of the demonstrator, because as we've been saying, this is targeting students who, most of the students we are talking with don't know the existence of netcdf, so there's not much point in looking at that. But I also want to mention that there is a follow-up, and the next version of the ECEM, and as well as the Clean for Energy is another demonstrator that was available. And the follow-up is through the C3S energy operational system, and a new visual demonstrator will be available in the coming months. So please watch this space for the more technical oriented people. We also we received quite a lot of praises for the demonstrator here on the questions, and thanks also for the offering. Some people are offering to translate also as we speak, so that's great. We'll follow up with you. Then, Kate, can you help me? Do you find other questions? There's a long list, and
yeah, well, no, thank you very much for the questions. Perhaps this one for yourself, Alberto, or Luke, but there was a question by Bernd again about ERA 5 land data. I mean, we're definitely, as Luke already said, we're definitely planning to move into ERA 5, which is going to be a finer resolution. So I guess it's watch this space, but I think the clarity about ERA 5 land in particular, Alberto, can you or Luke answer that one?
Yes, definitely. I think that falls into the category I was talking about. This more technically oriented people that don't. Yeah, I mean, it's not going to be available very soon, particularly on the demonstrator here. It may be available on the C3S Energy demonstrator, but it could be other tools as well. But again, this is more a kind of more technical type of question that students probably wouldn't have a knowledge about, whether it's a ERA 5 or ERA 5 land. We are more interested to communicate the underlying message and try to simplify the scientific content as much as possible for them.
I would still say to the teachers who are in the room to kind of watch this space, just for teachers who are here, to clarify, ERA 5 has both spatially and temporary a much finer resolution. As I say, that is in the pipeline. So if you wanted to do any learning or any inquiry-based learning, which is more finer, so you really want to get as close to your local scale as you possibly can. So for example, here you're looking at East Anglia or a part of East Anglia in particular. So you're looking at flooding events, for example, so an hour-to-hour precipitation data would be quite useful. But as Alberto said, this is something that's down the lines. This is not something that's going to happen overnight or within the next few months. This is going to be something to look out for, which is why I would encourage everybody here to stay with us in the long run, because I think there's some really exciting things coming online in the future, and that would be one of those things.
Yeah, there's another also comment. I don't think it's a question, but it's a comment from one of our attendees, and thank you for also attending from Somalia, and it's expressing interest on the tool, and of course at the moment is as you can tell, it's geared towards Europe, but there are plans also to expand to a wider domain and address some of the interest that we've been getting from people like you are attending and providing comments. So thank you for that. One question, yeah, I would like to, maybe the last one we cover. And thank you also for the active participation from Lawrence. So the tool seems very powerful. Could a version also be used to share data by energy meteorology researcher in the mind of open science to the world? For Kit, or maybe, I don't know if Carlo wants to say something as well on this.
Well, in a sense, as a way of sharing the data, I guess the underpinning climate data store I was mentioning in my introduction is probably the way forward. Now, this from a program point of view, this is an application that is meant to promote the service and make it relevant to the specific community we are addressing here, so the schools and teachers and so on. So you can certainly use it for other purposes, and that's part of the innovation. But in a sense, I think the infrastructure that underpins what we are doing in this specific case is probably more powerful for the purpose you had in mind.
No, not to add in that, just to echo what Carlo said. This obviously demonstrator has been specifically aimed for teachers and students. So we're thinking of 11 to 18-year-olds in particular, but and then there'll be perhaps WEMC ourselves or other agencies will be working with Copernicus to develop tools for specific uses. But there is one more question I'd like to add before we part, and that is there's quite a few questions saying, is this video going to be available for students? Absolutely. When we make this webinar available, we'll also make the video demonstration itself available. I know how very short videos can be useful for students. If you wanted to play it before you get the kids working on the tool and using the tool, you're very, very welcome. We'll make sure that the video is available separate from the webinar, as well as in part in the webinar recording also.
Okay, so thank you. So we're coming to a close now, and we would just want to mention a couple of things before we close. So the first one is that as part of our contract under the C3S, we are keen to get more feedback, particularly from teachers and students, and other people also are welcome to attend. But as we said, the target needs to be the students in the first place, so high school students. And for that, we are organizing a stakeholder workshop, which will be held pretty soon in 20 days time, 20, on Monday, 27th of January, 2020 at 12 UTC for 2 hours. So this is a save the date. More details will become available soon, but you are already able to register through the link that is given on the web page there. So on the slide. And now going to the closing, and I would like to thank all the presenters. I mean, this is we wanted to highlight with this presentation the importance of the work that has come from different people with different backgrounds in the team, as you saw. So each one of us given a bit of their flavor and input on what they've done in the project, but it's been a tremendous teamwork, and I hope you see the results of this teamwork. We are very pleased with what we achieved so far, and this obviously couldn't have been without the help and support from the Copernicus Climate Change Service. So this is all under the umbrella of C3S, as we've said, and you will see it in all the branding, but particularly the support and the guidance has been tremendous. So we like to thank them, and we'd like to thank all the attendees here for attending, providing their feedback, and please continue to be in touch and provide feedback as we move on, and because we do want to continue to improve the tool. And this is just one step in our journey, and there'll be many more to come. So thank you very much again, and stay in touch.